Good morning, guys. All right, so just moving along in our Math 30-1 course. Next chapter we're going to start is going to be called trigonometric functions. Okay, so if you're following along with the textbook that we use, this is now going to be chapter 5. We have 4 sections. We're going to start on the graphs of y equals sine x and y equals cos x. Section 2 is we're going to apply transformations to both of these graphs. Section 5.3. We do the graph of y equals tan x, so that the tangent function. And then section 5.4, we're going to do kind of I would call a sinusoidal function application section. A lot of like cyclical motion like that, and how we kind of deal with some of those problems. So moving on, we have to figure out what the graph of y equals sine theta. So first definition, I have a sinusoidal curve is the name of a curve that fluctuates back and forth like a sine graph. A curve that oscillates repeatedly up and down from a center line. Okay, so when we're graphing this, we're graphing y equals sine theta. Instead of calling this like the x and y axis, this is actually going to be the theta axis. So this is going to be the angle. And then the y is going to be the value of sine theta. Okay, so looking at this, we're going to start at our angle of 0 radians. Okay, now the sine on our unit circle is the x value, is the y value on our unit circle. So at an angle of 0, we're going to start here at 0, 0. Okay, next I'm going to go all the way up to pi over 2, or 90 degrees. And the value of sine at pi over 2 is going to be 1. If we come back down to pi, the value of sine is 0. If we come back down to 3 pi over 2, the answer is -1, and then back up to 2 pi. If we go in the opposite direction to negative pi over 2, that means we're starting at 0 and going to negative pi over 2, which would be this point here. We have -1. Negative pi would be 0. Negative 3 pi over 2 is the same as positive pi over 2. Is going to be 1. And 2 pi would be 0. So the curve we're getting looks like this. Like that. All right, so this is what the graph of y equals sine theta looks like. It doesn't stop there. There'll be arrows here, arrows here. This graph's going to continue on. We're going to take a similar approach for y equals cosine theta. Okay. Now, except for cosine theta, we're now looking at the x values on our unit circle as well. So when our angle is 0, cosine is 1. When we hit pi over 2, our value of cosine pi over 2 is 0. At pi, we hit -1. At 3 pi over 2, we hit 0. And this graph looks like this. Oops. Okay, this is how our graph of y equals cosine theta is going to look like. Now, guys, my diagram was not very good over here. This should be a much smoother curve. I'm just going to erase part of this. Should have done a better job than this. So this curve is going to be more of a curved graph like that and like this. Okay, does a bit better of a job at this one over here. So this is what the graph of y equals cosine looks like. Now I'm just going to go back to sine. Just a couple key differences here. If we look at the start, so if I say this graph starts here, the graph of y equals sine theta is kind of passing through the origin going up. Okay, is how this graph starts. Whereas cosine graph, it starts at the top at 0.01 and starts going down like this. Okay, but otherwise these two graphs are really the same shape. I'm just kind of starting at different spots. Amplitude, I'm just going to go back over here. If I call this line my midline, the amplitude is going to be the distance from here to here, which in this case is 1, or from here to here, which is still 1. But it's going to be the distance from the midline to the max or the midline to the min. We call this the amplitude. That's how we're going to define the amplitude. The period, you look at this graph, if I go from here to here, this distance, which in this case is 2 pi, is the length of one full cycle. Now, it could have gone from this point to this point, or it could have gone from this point to this point. It doesn't really matter, because the distance is always going to be 2 pi, or from this point to this point. But the length of one cycle of the graph is going to be what we call the period. Okay, so for example 3, we're just going to be applying transformation rules that we've learned earlier on in our transformations unit, specifically to trig functions. So for the first one, we have the graph of y equals sine theta given over here, and we have the graph y equals negative sine theta. So what this is going to give us is a reflection in the x-axis. So in other words, this point is going to come down here. This is invariant, and our new graph is going to look like this. So this is going to be a graph of y equals negative sine theta. All right, example B, we have y equals 3 sine theta. This gives us a vertical stretch by a factor of 3. Okay, so that's what it's going to do over here. So the points here, this guy has y value of 1, is you can get stretched up to here, where we have a y value of 3. This stays invariant. This is going to come down to negative 3. So this graph is going to look like the graph. The drawing is not very good. It's kind of tough to do on this screen that I'm writing on over here. But this is how our graph of y equals 3 sine. So notice over here, the amplitude of this graph is still 1. Okay? Whereas the amplitude of this graph is now going to be 3. Okay, so I'm just put over here below it. Amplitude equals 1, whereas this one is amplitude equals 3. Okay, for us over here, graph of y equals a sine of bx, the amplitude equals the absolute value of a. So if this a value is really the vertical stretch factor, but if a is negative, we also have a reflection in there. Okay, so the reflection is not going to affect the amplitude. So in other words, we're never going to have a negative amplitude, even if we have a negative a value. Okay, so if the a value is negative 2, the amplitude would be 2. If the amplitude was 5, if the a value was 5, the amplitude would be 5. Okay, now what this b value does, this is a horizontal stretch by 1 over b. Okay, so if my period was 2 pi and I have a b value of 2, that means I'm stretching it by a factor of 1/2. 2 pi divided by 2 would be pi. So it's going to be the new period over there. We'll show you some more examples of this in a second here. All right, say the period amplitude of each graph. Okay, so in this case, our amplitude equals 4. Okay, our period equals 2 pi over b, so therefore 2 pi over 3 is our period. Okay, for part b, our amplitude it's just going to be 5 over 2. Okay, so even though the a value is negative 5 over 2, we're describing the amplitude. So we say amplitude is 5 over 2, but there's also been a vertical reflection. But if I'm asking for the amplitude, it's just going to be just 5 over 2. Our period is 2 pi over 8, which is pi over 4. For the next one, our amplitude is 3.4. Our period is 2 pi over pi over 2. Okay, a bit of work with fractions over here. I'm just going to make this 2 pi over 1. So this is fraction divided by a fraction. I'm just going to make this 2 pi over 1 times 2 over pi, cancels, cancels, equals 4. So the period of this graph is going to be 4. Okay, so determine the equation of each graph in the form y equals a sine bx or y equals a cos of bx. Okay, so first thing over here, in this case, we're measuring the angle in degrees for this guy over here, not in radians. Okay, so we're just going to use the formula in degrees instead of radians. Looking at this picture, from here to here, this distance is 3. Therefore, our amplitude is our a value is going to be 3. Okay. Now our period from here to here is 120 degrees. So what we saw before was period equals, I was using 2 pi over b before, but I could use 360 over b if I'm using degrees instead of radians. Well, if I just multiply both sides by b and then divide both sides by p, we get our b value is 360 over p. So these are really the same formula over here. Okay, so we know that 120 degrees is the period. So our b value is 360 over 120 equals 3. Okay, so this question is going to be y equals 3 sine of 3x. Okay, guys, there's no cosine for this one over here. Okay. All right, this is going to be a cosine graph. Now, the reason we know it's a cosine graph is because this graph is actually starting at the top. If you remember in the previous example, sine graphs start in the middle, going up, passing through the origin, where cosine graphs start at the top. Okay, so looking at this from here to here, this is going to be a distance of 2.5. That's our amplitude. Okay, from here to here, our period equals 4. Okay, so what we're going to do is let's figure out our b value now. Okay, and sorry guys, I should have specified before, but this is going to be measured in radians. So therefore, our period is going to equal 2 pi over b, which is 2 pi over 4, which is pi over 2. Guys, I messed this up, sorry. Let me back up for a sec. P equals 2 pi over b, therefore b equals 2 pi over p. Okay, so we're solving for a b value here. So that means b equals 2 pi over 4, which is our period, which is going to be pi over 2. So before I said p was pi over 2, but no, actually it's b that's pi over 2 here. Okay, so what's our equation going to be? It's going to be y equals 2.5 cos of pi over 2 x. Okay, and that's going to be our answer for this cosine equation. Okay, part C. The graph of y equals a cos of bx has a maximum value of 0.52. Its next minimum value is 2 pi over 3, negative 5 over 2. Determine the values of a and b. What we're going to do here is I'm going to graph 0, 5 over 2 is this point here. Your next minimum value here, they're saying, is 2 pi over 3, comma, negative 5 over 2. Okay, so the idea about having these graphs over here These graphs are periodic, which means they keep following the same pattern going over. So this is the minimum, the maximum. This is going to be the minimum. That means the next maximum should be over here. Okay, well, if we know that from here to here is 2 pi over 3, well, it's going to be the same distance as from here to here. So therefore, this one must be 4 pi over 3, comma 5 over 2. And our graph is going to look like, it's going to keep on going like this. Okay, so looking at this, I hope we can see that the amplitude is 5 over 2. The period from here to here is 4 pi over 3. So what we have so far, we know that A equals 5 over 2, and B equals 2 pi over P equals 2 pi over 4 pi over 3. Make this an over 1. And I'm just going to multiply by the reciprocal. The pi's cancel out, equals 6 over 4, which is 3 over 2. Okay, so there's our B value that we just saw for here. So our equation is going to be y equals 5 over 2 cos. So we're just following this equation over here. And our B value is 3 over 2x, like that. And there is our equation there. All right, guys, I hope this made sense. And please send me any messages if you have any questions about this. I will see you in the next video.